Welcome to our third lesson on chemical equilibrium. Today we're going to talk about calculating a value for the equilibrium constant, KEQ. You have been writing expressions for KEQ from balanced equilibrium equations, and if we know the concentration of the reactants and the products of that system, we can calculate a numeric value for KEQ, and that can be useful to us in solving problems in equilibrium. So if we consider the following reaction, we have carbon monoxide reacting with hydrogen to produce methanol. This question is asking us, what is the value of the equilibrium constant? So it's asking for a numeric value. So that's KEQ. What's the value of KEQ at equilibrium if we measure the following concentrations? Now you'll see they've provided the temperature of the reaction. If you recall, K changes at different temperatures. So the temperature is just mentioned because the K value will change depending on the temperature, but we don't do any calculations that actually use the temperature. So you'll see these numbers in these questions, but we don't actually use that number as part of our calculation. So you've had some practice writing values for or equilibrium expressions for these constants from the information in the balanced equation. So in this case we have the concentration of methanol divided by the concentration of carbon monoxide, gas, and the concentration of hydrogen. And the concentration of hydrogen is squared. So be careful, remember with these coefficients in the balanced equations, they're going to pop up as exponents in our equilibrium constant expression. These are all gaseous reactants and products, so they're all included. Also, don't forget to put products on top and reactants on the bottom. So since we have actual values that we can sub in, we're given the concentrations at equilibrium, we can find a value for KEQ. So the concentration of methanol, 0.55 moles per liter, divided by the concentration of carbon monoxide, 0.17 moles per liter, and also in the denominator the concentration of hydrogen, 0.030 moles per liter squared. So don't forget to square that value. That's a very common error that people make, is forgetting these exponents. So we can use our calculator here and calculate a value for KEQ divided by, and I get a number. I get 359. So I'm going to give that 2 significant digits, and so my value for KEQ is 360. So what does this value tell us? 360 is bigger than 1, so it's saying in general there's a little bit more product present than reactant at equilibrium. You can see that that's perhaps true. In the grand scheme of things, this value is actually fairly close to 1, but we're tipped slightly in the balance. We're tipping the balance slightly in favor of products here. You may have noticed there are no units on this number, so we've got all of these units up here, but no units on the answer, and I'm going to tell you 2 reasons for this. One is, if we look and see what the units are, we can cancel out moles per liter, and we're left with, in the denominator, moles per liter squared. So the official units of this number are liters squared per mole squared, which doesn't mean anything. Well, it doesn't mean anything to me. It's not useful for us conceptually to know that those are the units of K. The other reason we don't include units for the equilibrium constant is that different equilibrium constant expressions have different amounts of reactants and products present, and it has also have different exponents on the concentrations here. So some equilibrium constants will have units of moles squared per liter squared, or liters per mole, or liters cubed per moles cubed, and that's another reason we don't bother including units for KEQ. So after all of the harassment you've received about having units on numbers, you're off the hook for these ones. This second example is asking us to apply our understanding in a different way. So it says the constant for this reaction is 15.4. So they're giving us KEQ right off the bat. Again, we see that temperature, which we're not going to do anything with, but it is there. They're also giving us the concentration of nitrogen and of hydrogen. And the thing we're being asked to find, they say at the end, what is the concentration of ammonia at equilibrium? So we know the constant, and we know the equilibrium concentrations of N2 and H2, and we're asked to find the equilibrium concentration for NH3. So let's write an equilibrium constant expression. Concentration of nitrogen gas times the concentration of hydrogen gas cubed divided by the concentration of ammonia squared. And we can substitute in the values that we've been given. KEQ is 15.4. The concentration of nitrogen is 0.035. I'm not going to include units on these numbers because since K doesn't have units, they're not going to cancel anyhow. The concentration of hydrogen, 0.54 cubed, divided by the concentration of ammonia squared. So what we're after here is the concentration of ammonia. So we can rearrange this expression to solve for the concentration of ammonia. Some people are more comfortable putting the thing they're solving for on the left-hand side. That's generally what I do when I'm solving for an unknown. So we have 0.035 times 0.54 cubed divided by 15.4. We don't want to know the concentration of ammonia squared. We want to know the concentration of ammonia not squared. So we can take the square root of both sides, and that will give us the concentration of ammonia if we can solve this number here. So we've got 0.035 times 4 and the square root, and I get 0.019 moles per liter. We know the units are moles per liter because by definition, how we've defined this equilibrium constant, the units for the concentration of ammonia are moles per liter. So this is a valid thing to do, even though the units aren't appearing up here. So 0.019 moles per liter is the concentration of ammonia at equilibrium if the concentrations of nitrogen and hydrogen are the ones that were given. So as far as questions to try, I would like you to take a look at page 444 and try number 31 and number 32. See how they go and bring your questions tomorrow.